Let us just discuss one more LeetCode problem, that is amount of time for binary tree to be infected. You're given the root of a binary tree with unique values and an integer start at time 0, and infection starts from a node with value start. Each minute a node becomes infected if the node is currently uninfected and the node is adjacent to an infected node. So we can just understand the problem statement by looking at the example. So here 3 is this start node. So at minute 0, 3 is the only node that is infected. Then at minute 1, all the nodes that are adjacent to 3 will be infected. Here 1, 10 and 6. So at minute 1, nodes 1, 10 and 6 will be infected. Then at minute 2, all the nodes that are adjacent to 1, 10 and 6 will be infected. But here 10 and 6 has no childs, so only 5 will be infected at minute 2. Then all the nodes that are infected will be infected at time 3 is adjacent to 5, right? So only 4 is there, so 4 will be is the only node will be infected at time 3. Then minute 3, then at minute 4, 9 2. So this is a tree that is given to us. I can just make it smaller a little bit. It's fine. So if we have a mechanism which tells that which node is connected to which nodes, so then it will be easier for us to find, right? So I may say we have to have a mechanism like 1 is connected to 3 and 5, right? Then 3 is also connected to 1 and 5 is also connected to 1. Then 10 is connected to 6. 10 and 6, sorry, 3 is 10 and 6 is connected to 3, but also 10 is connected to 3. And okay, here it should be 6, not 3, and 6 is also connected to 3. The same way 5, right? So 5 is connected to 4, 1 and 4, but 4 is also connected to 5, and 9 and 2 is connected to 4, and also 4 is connected to 9 and 2. Then 9 and 2 is also connected to 4, and so here we can get that. So it's more like a map of integer and integer to vector. So this is a mechanism that will help us to solve this problem. And we'll be having another map that will tell us that particular node is infected or not. So, and we'll be having a queue, right? So at time 0, 3 is the only node. Here start is 3. Let me just write start is 3. So 3 is true at time, true means it's infected. So 3 is infected, so 3 is true. All the nodes that are connected to 3 will be pushed into the queue, that is 10, 1, 10 and 6, right? Then it will be popped from the queue, and all the nodes that are connected to 1 but not infected will be pushed into the queue. But before that, these 3 nodes has to mark true because these 3 has got infected. 1, 10 and 1, 10 and 6, right? 1, 10 and 6. Then all the nodes that are connected to 1 but not infected, connected to 3 and 5 are the nodes that are connected to 1 but 3 is infected, so only 5 will be pushed. Then all the nodes that are connected to 10 and 6 will be pushed into the queue. Here 3 is the only node that are connected to 10 and 6, and it is true, so we don't have to push anything further. So again, 5. Okay, this is not I supposed to do. So 5 will be again popped from the queue, and all the nodes that have, okay, before that 5 should mark that, okay, I have 5 is already infected. So all the nodes that are connected to 5 but not infected will be pushed into the queue. Nodes are 1 and 4. 1 is already got infected, so 4 is the only node. So 4 will be pushed into the queue, and no further element will be pushed into the queue. Then again 4 will be popped, 4 will be popped, and all the node before that 4 should be marked that, okay, it gets infected, it is infected. Fine, so all the nodes that are connected to 4 but not infected will be pushed into the queue. So nodes are 5, 9 and 10, and 9 and 2. 5 is already infected, so 9 and 2 will be pushed into the queue. Then again 9 and 2 will be popped from the queue, and all the nodes that are connected to 9 and 4 but not, okay, before that 9 should be marked true and 2 should be marked true, I mean infected, right? So all the nodes that are connected to 9 and 2 but not infected will be pushed into the queue, but no further node because 4 is already infected. So here we'll end our loop, right? So, and each time we pop the queue, pop from the queue, we will increase our timer by 1. We will increase our timer by 1, and finally the answer will be in the timer we'll return from here. So let us just dive into the code, and it is very simple. Okay, first what you have to have is that map that I was discussed. Okay, that is, I hope this map, yeah. So let us create that first. Okay, unordered map, and it is into a vector that I've already discussed. Okay, just call paths. Okay, fine. And void creating paths. This function will basically make the map for us. So if first if root is null, then we will simple return. I guess I have deleted one right back. Okay, fine. This simple return. If if root arrow left is not null, then paths of root arrow file is dot pushback, because it's a vector, right? Pushback root arrow left arrow val. But also we have to do this because left is also connected to the root, right? So root arrow, okay. Root arrow left val, then pushback root arrow val. And similarly for the right child, if root arrow right is not equal to null, then we can do the same thing, but we have to just change left to right. Here it is. Right, fine. And let's call the function creating paths, I guess. Creating paths, yeah, right. Root arrow left, and then creating paths. I guess. Okay, one smelling is defined. Root and right. And if you see, if there is only one node, so of course the answer should be 0. So we can just have here if root arrow left is equal to null and root arrow right equal to null, then return simple 0. Otherwise we can have one first of all we have to make and into bool, that is infected which node it is for keeping track which node is infected. Let us call infected. And as we discussed, we need a queue of vector of in. Let us call u. So at time 0, right, so infected of start is true, and all the nodes that are connected to, okay, before this we have to call our function, otherwise nothing will happen. Paths of that's fine, okay, and all the nodes that are connected to start node will push into the queue, and we will get how paths of start. That's fine. While queue is not empty, we will have the same thing. Terrain nodes queue dot is front, then queue dot pop. But before that we have to initialize a variable called timer. Initially timer will be at 0, and each time the loop execute, timer will increment by 1. So all the nodes, let's just have one node vector. It will be adjacent, that is AJ. So all the nodes they auto in the nodes in nodes. So for, and of course we have to mark this true, right? So infected of name is true, that's for sure. Then all the nodes that are adjacent to infected, to node n, right? So all nodes, it can be called neighbor, fine. Paths of in, if that neighbor infected is not infected, then we can just push into adjacent vector adj dot push back name. And first of all, and of course we have to push in the queue adjacent push adj. But if there is no node that is if we are here 9 and 2, so adjacent vector will be empty, so there is no need to push again into the queue. So we have to handle that. So if adj size is not equal to 0, then we'll push that, otherwise we'll go ahead, and in the end we will just return our timer. I hope it works. Error. Fine. Infected. Okay. Infected. Spelling mistake. Infected. Fine. Okay. One more. That's fine. Fine. So okay. Let's submit that. Okay. So it is getting accepted. Thanks for watching.